Okay, hello everyone. Here is Liang. You can call me Peter. Today we are going to learn something about limited. So today's topic is how to evaluate limited. So I did some work and we can see for different limited question, usually we can only use 6 different methods to evaluate them. So I will go through it one by one, okay? First one is directly just plugging in, okay? Okay, so those are for most of questions that without any some technique. Okay, for example, if you have limited x go to 1 and x squared plus 1, how do we do this one? Very easy, just plugging in 1 to here and you have 1 plus 1 is equal to 2. Okay, pretty easy. And the second method will be different. Okay, so you can see this kind of question is only for the question you could just plugging in the volume, but in some cases you couldn't. Okay, for example, if you have x equal to go to 1 and we have a rational function here, you have x squared minus 1 and here is x minus 1. You can see if you directly plug in, the number will be 0 over 0. We know 0 over 0 could be any number. Could be 1, could be 2, could be infinity, could be any number. So we couldn't just plug in. So we try to simplify this one by factoring. X minus 1, here is x minus 1 times x plus 1. Okay, limited x go to 1. Okay, then you can easily see these two could be cancelled out, right? Then you only have x go to 1 and x plus 1 as a denominator. Okay, then you can directly plug in x go to 1, so we have 1 over 2. Okay, simplify by factoring. Okay, this is the second method. And the third one, okay, is also simplified, but this time we simplify by rationalization. Okay, I give you this kind of question: x go to 0 when 4 plus x minus 2, okay, divided by x. Okay, you can see this kind of question, you have a square root or something, a radical form, right? Of course, for those kind of questions, we use rationalization because we want to remove the radical form. So for this one, we can multiple congruent term for this. Do you know congruent term? That is for that kind of form a plus b, then you have a minus b. Okay, for this one, because we have a squared minus b squared, you can use this method to remove the radical form, right? So for this one, let's multiple 4 plus x minus 2 multiple square root of 4 plus x plus 2. Okay, since you multiple one term here, you also have to multiple one term as a denominator part. Okay, then it means you only multiple 1. Okay, it's the same term. Okay, but this two is a minus b times a plus b. So we can say it's just a squared minus b squared. For this part, it's just 4 plus x. And the minus 2 squared is minus 4. Okay, x times square root 4 plus x plus 2. Okay, limited x go to 0. And here 4 cancel out. You have 1 and 1. Also simplify, here is 1. Okay, so we have x go to 0. Here is 1, here is 4 plus 1 plus 2. Okay, when x go to 0, we have square of 4, which is 2. So 2 plus 2, 1, here is 1 over 4. Okay, this is a third method. Simplify by rationalization. Okay. And the next one is divided by highest whole order. Okay, what's that mean? That's only for the situation that we have when we have limited x go to infinity, and we have a rational function as the part we want to evaluate. Okay. So in this case, for example, like let me give you an example. X go to infinity, and we have x squared plus 1. Here we have 2x squared square minus 2x plus 1. Okay, how do we evaluate this? Okay, then we can see which term have the highest power. Is x squared, right? This one is also x squared. X squared is highest power. So we divide by x squared for each term. Divide by x squared. So here is x squared divided by x squared plus 1 over x squared divided by 2x squared divided by 2x squared minus 2x divided by x squared plus 1 divided by x squared. Why do we do this one so complex? Because this one is just 1, right? This one is what? It's 0. It's 0. Since limited x go to infinity, 1 over x squared is 0, right? This one is 0. This one is just 2. This one is also 0. This one is also 0. So what's the answer? 1 over 2. Okay, pretty easy. It's kind of similar question at the pre-calculus level. Okay, you may see this one before. Okay, next one. So the fifth method, we call it left, right, limited. Okay. Remember we have the how do we determine if we have a limited at some point? Okay. We say we have a left limited and right limited, and if they are equal to each other, then we say we have limited. Okay. If they're not equal to each other, we say the limited at this point do not exist. Okay. For example, if we have x minus 1 absolute value divided by x minus 1. Okay, for this question. Of course, you can see x equal to 1 is the point that we want to evaluate, right? Okay, x equal to 1. Sometimes you see absolute value, sometimes you see the piecewise function. It doesn't matter. Okay, we could only determine the point that's on the left side and right side. For this one, we couldn't directly evaluate. We can only separate as left side and the right side. So we have x go to 1 minus, actually this means left side, and limited x go to 1 positive, it means right side. For x minus 1, if we have any x less than 1, this value is just x minus, is negative x minus 1, right? Divided by x minus 1. And for any x value is bigger than 1, then we have just x minus 1, okay? So we have x minus 1 divided by x minus 1. And this part you can easily say is negative 1, this part you can say is positive 1. The left side and the right side are not equal to each other, so we say this limited do not exist. Okay, since left side and right side are not equal to each other. Okay. And finally, the last technique. Squeeze theory. Okay, sometimes we call it sandwich theory. Okay, only for the situation that you see a sine or cosine. Okay, because sine and cosine have a neutral range. Sine and cosine, for example, if you have this limited x go to infinity, how do we solve this one? We know sine have a neutral range, which is less than 1, less or equal than 1, and bigger or equal than negative 1. Okay, so let's do divide by x for each term. Okay, we can assume x is a positive number because x is going to infinity, right? It doesn't matter. You don't need to consider the converting reverse the inequality sign. Okay, so for this one we have this relation, and next part let's plug a limited sign for each term. Okay. So you see this one is what? 0, right? This one is what? 0, okay? So we can say this number is actually less than 0 and also bigger than 0. So the only possibility is this number is also equal to 0. Okay? Less than a number and bigger than a number. And these two sets have the same number. So that's the only situation, that's the only possibility for this limit here. Okay? So yeah, that's it. That's all of 6 techniques you're going to learn on the first chapter for the calculus. In the future, maybe after chapter 3, we're going to learn another technique we call Hospital rule. That's another technique we're going to learn, but that's not something you have to figure out on chapter 3. Okay, so yeah, that's all. Thank you for being part of my class and have a great day.